Hello, statisticians! Mr. Youngsaver here from Skew the Script. Today we're going to explore where there was a secret hero during the event in baseball known as the Marlins Miracle. Let's skew it! Today's lesson is on normal curve calculations. Let's jump in. This is Jose Fernandez, who was a former pitcher in Major League Baseball. Fernandez was originally from Cuba. In interviews later in life, he described growing up in poverty in Cuba, often playing baseball with sticks and rocks as a child because he couldn't afford official equipment. When he was a young adult, after 3 failed attempts, Fernandez was able to successfully defect from Cuba, traveling by boat to the United States. On that last journey, he famously saved his own mother from drowning on the rough seas. With Fernandez and his family risking so much to come to the United States, once he arrived, he worked incredibly hard and became a highly successful baseball player. He worked his way up and eventually became the best pitcher on the Miami Marlins Major League Baseball team. He was known throughout the league for his cheery attitude, and he was wildly popular among the Cuban American fan base in Miami. Then, unfortunately, in 2016, tragedy struck. Fernandez died in a boating accident off the coast of Miami at the age of 24. This tragedy sent shockwaves throughout baseball, his team, and the city. The next day, the Marlins, his team, were scheduled to play a game against the New York Mets. And here are some somber scenes from the field that day.
Difficult day in Miami for Marlins fans, even for Met fans, for baseball fans. Marlins Park. This about 3 hours ago, D. Gordon with Jose's glove and Jose Fernandez cap and a baseball. Tonight, the Marlins will play a baseball game just 36 hours from learning that they had lost their ace.
I don't know how they're going to do it, but the Miami Marlins are going to play a baseball game against the Mets tonight. I was especially struck by the poignancy of the national anthem, a song we hear every day. But for a young man who risked everything to be a part of this country, it rang especially true today.
But by the time the game was over, it became known as the Marlins Miracle. And here's why. D. Gordon, one of Fernandez's best friends, was the first batter up for the Miami Marlins. When he stepped up to the plate, he had not hit a home run all season in over 300 at-bats. Then, in the first at-bat of the game, he did this.
Gordon has started to look like the D. Gordon of last year. Gordon to right. It's deep. And it's gone! D. Gordon has hit it out, and the Marlins have a 1-0 lead.
That special home run and that special moment became known as the Marlins Miracle. It made headlines across the country as the nation was inspired by D. Gordon's heroic hit. But here's the thing. If we look at the situation a bit more carefully, there may be another potential hero in this story. A hero that can only be revealed through the study of statistics. And that potential hero is this guy, Bartolo Colon, the pitcher on the other team during D. Gordon's at-bat. So that raises our key question for today. What role did the pitcher play in making the Miami Marlins miracle happen? With that question in mind, let's move into our guided notes. We're going to cover two topics today, starting with using values to find proportions in normal curves. So let's talk about this pitcher, Bartolo Colon. At the time, he was 43 years old. He was loved by fans, players, basically everyone who interacted with him. And he had an iconic nickname, which he fully owned himself and that he used to refer to himself, quote, Big Sexy. And there's a reason for that, because at 43 years old, he was still making plays like this one.
He's just keeping the ball away from Bohr the whole game. He wants to get it. There, ball.
Behind the back slip, and he got him! Oh, wow! It's so easy for Colon right now that he's able to put some mustard on it.
Oh, my gosh. There's a bag of tricks.
This man will live forever. Like Bob Cousy. He's almost as old as Cousy.
He's smiling. He knew it.
Unbelievable.
And also impressively, at 43 years old, Colon still threw very fast. Among first inning fastballs that he threw in that 2016 season, his average pitch speed was 89.4 miles per hour. To put that speed in context, that means that the hitter standing 60.5 feet away from the pitcher's mound only sees the ball for less than half a second of flight time before it reaches them. It turns out that if you look at the distribution of speeds among all of Colon's first inning fastballs that he threw that season, they are well modeled by a normal curve, with a mean of 89.4 miles per hour and a standard deviation of 1.7 miles per hour. And so, according to the empirical rule, about 68% of his first inning fastballs were between 87.7 and 91.1 miles per hour, or within one standard deviation of the mean. 95% of his fastballs were between 86 and 92.8 miles per hour, within two standard deviations of the mean. And 99.7% of his fastballs were between 84.3 and 94.5 miles an hour, or within three standard deviations of the mean. So with this distribution, we can look at a question like this. What percent of Colon's fastballs were 92 miles per hour or faster? As with all normal curve problems, to tackle this, we could use these three steps. First, draw and label the curve, then perform the calculations, and finally answer the question in context. Following these steps will make sure that you get full points. The first step to answering this question is to draw and label the normal curve associated with Colon's fastballs. And so we do that here. And note that we've labeled that curve, the curve is normal, with a mean of 89.4 and a standard deviation of 1.7 miles per hour. And we put labeled tick marks showing those standard deviation markings along with the variable name. So to answer the question, we need to find the proportion of fastballs that were at least 92 miles per hour. That phrase, at least, means that 92 is the least speed we're looking for. So we're looking for 92 miles per hour or higher. So we're trying to find the percent of his fastballs that are in this upper shaded area, or the probability that this random variable is greater than or equal to 92, which we can write in this notation. Now that we have a good picture of what the question is asking, it's time for the calculations. And we can see that 92 is not exactly a convenient number for our curve because it doesn't fall on one of our labeled tick marks. It's not a certain number of standard deviations away that's very easy to see. So what should we do? Well, when you're between standard deviations in your normal curve, it helps to find the z-score and then use technology to finish up the calculations. So we can see that 92 is more than one standard deviation away from the mean, but it's less than two standard deviations away. So we can see that 92 miles per hour is between 1 and 2 standard deviations above the mean speed. To find out exactly how many standard deviations above the mean, we can find the z-score. Recall that the z-score shows you how many standard deviations a data value is above or below the mean. And recall that the formula for the z-score is this. The numerator is the data value minus the mean, which shows us the distance between the data value and the mean. Then we scale that difference by the standard deviation by dividing it. Hence, we figure out how many standard deviations the data value is above or below the mean. Our data value is 92, so we can drop that here. And then the mean and standard deviation come from the probability distribution we already have written. We substitute them in, and we find that a pitch speed of 92 miles per hour is 2.6 miles per hour above the mean. When we divide this by the standard deviation of 1.7 or scale it by that standard deviation, we get 1.53, which means that a 92 mile per hour pitch is 1.53 standard deviations above the mean. So using that z-score, we can try to figure out what percent of his pitches will be more than 1.53 standard deviations above the mean. And you can do this by using your preferred calculator or software. Note that we have short videos linked in the description that show you how to do this for Desmos, GnomeWorks, TI calculators, etc. So check those out before proceeding. So as shown in the video for your preferred calculator or software, we get an area of 6.3%. So 6.3% of his fastballs are at a speed of at least 92 miles per hour. And this should make some sense, because recall that the empirical rule tells us that 95% of data values are within 2 standard deviations of the mean. So only 5% will be outside of that, or 2.5% in each tail. Since our data value was only 1.53 standard deviations away from the mean rather than a full 2 standard deviations away, there is slightly more area above it, and 6.3% is slightly higher than 2.5%. Now that we have that proportion, our final step is to answer the question in context. So we can say that 6.3% of his fastballs were at least 92 miles per hour. So this means that at the age of 43, Colon was still throwing at least 92 miles per hour 6.3% of the time. That's quite impressive. So now that we looked at some of his fastest pitches, we can also ask what were some of his slowest fastball speeds? And that brings us to our next topic, using proportions to find values in normal curves. Specifically, we're going to answer this question. What speed is at the 5th percentile of his fastballs? That means that we need to find a speed that's only at or above 5% of his pitches. First step, as always, is to draw our curve. We're given that the pitch speed we're looking for is above about 5% of his pitches. So we've shaded an area that seems to contain only 5% of the probability below it. And we're trying to find the pitch speed at that spot, which we don't know yet. So we put a lowercase x there. Our goal is to find that unknown value. So using our notation, we'd say that the probability that our random variable, capital X, or pitch speeds, is at or below the unknown value, lowercase x, is 5% or 0.05. So we can ask what z-score leaves just 5% of the normal curve area below it. Again, linked in the description, we have some videos that take you through how to find the z-score using your own choice of calculator or software. So pause this video, check that out, and then return to this video again. So using your choice of technology, you found that a z-score of negative 1.64 leaves 5% of the area in the lower tail of a normal curve. In other words, we need to find the pitch speed that is 1.64 standard deviations below the mean. We can go right back to that formula for z-scores, but this time the data value is what we're trying to find. We know the mean and the standard deviation, and now we also know the z-score. So we can plug those values in. The data value x is the only remaining unknown, so that's what we can solve for. To solve, we need to undo this division of 1.7 by multiplying both sides by 1.7. That cancels the denominator here, and the equation gets simplified to this. So we can add to both sides to undo the final subtraction on the right side, and we get a value of 86.6 for x. So the pitch speed we're looking for is 86.6 miles per hour. Of course, the last step is to answer the question with context. So we can say that 86.6 miles per hour is at the 5th percentile of Colon's fastball speeds. So this means that an 86.6 miles per hour fastball is unusually slow for him. It's only faster than 5% of his pitches. Now, with this information in mind, let's watch the Miami Marlins Miracle clip again. But this time, pay attention to this part of the screen, which shows the pitch speed of his fastball for the pitch that he threw to Deke Gordon.
Of last year. Gordon to right. It's deep.
So that pitch speed in the clip raises our discussion question for today. Here are the locations of all the pitches Colon threw to Deke Gordon in that 2016 season. And note that pitches near the middle of the strike zone or towards the middle of that box shown there are considered the easiest pitches to hit. This dot right here shows the Miami Miracle pitch, and it was only thrown at 85.7 miles per hour. Given the location and that pretty slow speed, Colon was asked in a post-game interview if he purposely threw an easy pitch. Colon ended the interview early and walked out, without saying another word. So this brings up our discussion question for today. Do you think Colon purposely threw an easy pitch? Justify your answer using a normal curve calculation. And here's a hint to get you started. Using the normal curve from this lesson, try to find the probability of him throwing a fastball that's as slow as the one he threw to Gordon, 85.7 miles per hour or slower. With that in mind, take a moment to jot down your response to this question and we'll discuss it in class. That's it for today's Statisticians. We'll see you next time.